VMware. I'm going to open Kali Linux. We're going to learn cybersecurity. Yep. Fun. Where's Kali Linux? Go. Look at it. Kali Linux. So I'm not going to, just, show the. All right. Wait, it is working, right? It's not? Holy fuck, I thought it was working. Yesterday it was working. Wait, what what's going on? All right, let's just shut down. Oh no, it was working. Fuck. It was working. There you go. And then I also need to change my I think the pretty slow, not gonna lie. It is slow. Yeah, I need to change the default password. Definitely. All right, boys. Think is it fast enough? Yes, it's fast enough. Let's go. Let's go. Woohoo. Woohoo. It is fast. It is fast. It is fucking fast. You know, last time I installed, like last time I did the installation and whatever. Holy shit, it was slow. Installation and whatever. It was fucking slow. It was slow. I don't know if it's going to be if it's actually going to be slow still. I don't know if it's going to be slow still, but I'm having high hopes now. Hopefully, I have high hopes. Yeah, I just hope you know nothing bad happens. I can't. There you go. Do it. Yeah, boy. Yeah, boy. All right, let us begin. Ethical hacking. Ethical hacking. Ethical hacking. Ethical hacking cyber mentor.
Away from launching your website with Base 44. Since the beginning of the internet, there's never been such a fun, fast,
course, we're going to use Python again to write our own exploits. So it's going to be used throughout the course. You're going to see it again as a ethical hacker as well. You're going to go on to websites and you might need to download Python code or something we talk about.
Kylian Mbappe. Kylian Mbappe. How do I change the stream name? Oh, you can't do that. Oh, you can. Fuck yeah, you can. So learn cybersecurity slash ethical hacking day one. Learning cybersecurity. PS hacking.
layers, we think about the OSI model, and I'll introduce the OSI model here in a few videos. And it should all click once I introduce the OSI model. So if I brought in the OSI model up front, it might be
I think I also have a book. Oh, I need the note keeping, right? I need to have the note keeping. What was the note keeping? What note keeping did he mention? There will be no Pomodoro technique or like the timer or whatever. There will be none. There will be none. It's just how much I can learn. You know,
If you struggle with focus,
like how much I can learn as much as possible. Because I mean, like it's summer and it's the last day of April. You know, so like why not? And then I'm also going to. I plan on like uploading like one lecture for each course because I don't see myself, like sacrificing what I wanted to do this entire semester, this entire time, right? And now the fact that I'm on the dean's list, so what's the point of saying like, oh, I have to study, I have to do this, I have to do that. I mean, I can do what I want to do, right? Yeah, I'm not replying to any X replies now. Later. Seek help. People actually say seek help. Now want. Wait, there is something else I want. Oh, yes. Good, 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 good. I will drink it.
by step like this, and then go back and make a cheat sheet. I don't need this pictures anymore. I've been doing this for a while. So maybe I just say, hey, get current domain is get net domain. And then I say, hey, okay, get
What is the name of this? Enumeration? AD enumeration. Okay, actually, which note taking is best for ethical hacking? Obsidian, Notion, Joplin. Joplin is like, oh, Joplin is like too much, man. I mean, Joplin is really good. I'm not saying it's bad, but God, the storage for Joplin is like if you download Joplin, it's like almost 1 GB just for this. Just for note taking, it's 1 GB. That's a lot. Oh, Joplin. So if you want to, I mean, Joplin is good. Like that's really good. Yeah, I want to install. Joplin is good, but then like Joplin is like unnecessarily. But I'm downloading Joplin. It's not that I don't have any other choice. Just that I've used Joplin before, so I'm aware of it. I have used Joplin before, so I am a holy shit. Holy shit. I got 11,000 views for a video where I took Kylian Mbappe's. Oh, I do have it. You know what? You know what? Let's start again. That's completely fine. I used Joplin before. Just calm down, let's start again.
Object of another domain. Here's really quick with that. It is raining pretty hard here, so if the soothing sounds of the rain put you to sleep during this video and you can hear it, I'm very, very sorry. But the show must go on. So what we're going to be doing today is we're going to be talking about IP addresses. Now, if you've ever used a computer before and you're anywhat familiar with IT, you probably know what an IP address is. But I want to take this a little bit deeper in theory on why we use IP addresses, what types of IP addresses are out there, and talk more about protocols and how IP addresses are actually designed and made up. So I'm here in a Kali terminal, and I'm just going to type in a simple command, and that command is ifconfig. Now, if you've used Linux before, this might be familiar.
Oh, okay. Kali. ifconfig. Oh, it's so fast. Oh shit. Oh shit. Oh shit. You fuck. Right? Nope. Not doing that shit. No. Because if I open Kali Linux and then I do ifconfig, you're gonna find out, right? Yeah, like hell I'm going to let that happen. We'll do as much as possible.
To you, if you used Windows, it's similar to ipconfig. All I'm trying to do is bring up my IP address. So what we can see here is that we have an IP address, which is our INET. This is my IP address here.
Holy fuck, you can't see anything? Oh, you can.
I also have another IP address, this INET 6. This is what's called an IPv6 address. So we've got this INET, which is considered an IPv4, and this INET 6, which is considered an IPv6. Now you can notice right away that there's two different types of notations for these. This INET here is in a decimal notation, and the IPv6 is in a hexadecimal notation. We'll get to the importance of that in just a second. So when it comes to IP addresses, this looks probably pretty familiar to us. This is an IP address. This is how we communicate. We communicate over layer 3. And you're going to hear me talking about layers repeatedly throughout the course.
So I did that. So if I have config, holy shit, it is fucking fast. It is so fast. I downloaded Kali Linux before. I think the only reason it was slow is because, like, in terms of the storage and shit like that, it was okay. Okay, I used up way too much. I think in terms of the storage and whatever, it is too much. What I'm going to do is like, just delete everything. You know what? Fuck it, not now. As long as it's running. As long as it is running, we go.
Or at least throughout this part of the course, so that we can get familiar with how we're actually doing this. So I want you to be familiar with troubleshooting these layers and these.
Okay, so to get the IP address, like, so how to get the, oh, this will be, we call it theory notes, or you can't rename it, right? I don't think you can rename. Can you rename it? Okay, no, you can't. So this will be theory cybersecurity. Theory cybersecurity. We're just going to see that. How to get the configurations of IP address through Kali Linux. Wait. So you open Kali Linux if config.
These layers all refer to something called the OSI model. So when we talk about layers, we think about the OSI model, and I'll introduce the OSI model here in a few videos. And it should all click once I introduce the OSI model. So if I brought in the OSI model up front, it might be boring, might not make sense. So I'm going to introduce the OSI model near the end, and you're going to say, hey, yeah, that all makes sense. So what we've got here is we've got this IPv4 address, and this is the most commonly used format that we use today, right? We use IPv4 for mostly everything. And again, this is in that decimal notation. So when we see this decimal notation, it's just realistically a bunch of ones and zeros that are put together so that we have this human readable format. Realistically, all we're seeing here with 192, this first section here, this first octet, is actually just a bunch of ones and zeros. It's 8 bits. So we've got a range of 8 ones and zeros here. We've got another 8 here, and 8 here. So when it's all said and done, this INET, or this IPv4, is made up of 32 bits, 8 plus 8 plus 8 plus 8 here, and which equals 4 bytes. So another way to think about that is to think about it as, say, something like this: 1, 2, 3, 4, 5, 6, 7, 8, period. Okay, that is one section there. So we've got 8 ones that can make up this, and then we'd have another 8, etc. I'm not going to beat a dead horse here, but I do want to give you guys another.
Wait, I just want to reply to something. I begged Valentin, is it possible to? I just want to get some studies done, then get back to I actually begged Valentin. How stupid am I?
Another example. So if we go into our applications and we go to a text editor really quick. So the way this looks is something like this. We start with a number like 128. I'm going to try to space this out as best as possible. And all I like to do is think of 128 as my base. And this will make a lot more sense when we get into subnetting. So please, if you're confused by this, don't worry.
Wait, there's a lot of information. There's a lot of shit stuff. What IP address? Like, shall the explanation for IP address be that difficult? I don't think so. Like, the explanation for IP address being that difficult? Cybersecurity. Okay, there's a long lecture. So there is a huge load of lectures. Can you break it down? What is IP address into a simple explanation that covers literally the entire subchapter IP address? Boom, done. Dude, you don't need, okay. I don't want to share my IP address, but like you get the idea, right? You don't have to like learn this much. Yeah, I begged her. Oh, come on. I love What?
This is all theory right now. When we get into subnetting and we get hands-on, it'll make a lot more sense, I promise you. So let's say we have ones and zeros here. If we have a 1 for each of these sections, and I'm going to space this out again as best as possible, it's not pretty. But if we have a 1 for all of these, this equals 255. Why does this equal 255? Well, you take this, and all these numbers add up. 1 plus 2 plus 4 plus 8. All this adds up to 255. So let's say if we didn't have all ones and zeros, we had just some ones enabled, like these last 3 here. Okay, well, this would equal 7, because we have 4 plus 2 plus 1 equals 7. So our first number, or whatever number this applied to in the octet, would be 7. So if we had 7.7.7.7, it would just be this numbers repeating over and over. These numbers repeating over and over, right? So be 0.0001111 dot 0.0001111, and so forth. So this is kind of what it looks like behind the scenes, because again, a computer is just ones and zeros. We're all binary. So what we're going to do is we're going to close this out. And we're going to talk a little bit of other theory when it comes to this, and why INET or IPv6 and why IPv4. So let's close this and let's talk about IPv4. So I'm going to bring up a calculator. And with IPv4, we have these 32 bits. So what we can do is we could take two.
So IPv4 is a 32-bit. IPv6. So IPv6 is now being used. We do use IPv6 because this was done 3 years ago. But people do use IPv6 now. Like mine is an IPv6. Whoa, what's going on? Dude. Oh my God, man. I'm getting like comments after comments.
To the 32nd power. And this is the possible amount of IP addresses that we could have. So we have somewhere in the 4 billion range of IP addresses. Well, spoiler alert, we don't have only 4 billion people on Earth, right? We're up to 7 something billion at
Yeah,
this
so you
point.
need IPv6.
And all these IP address spaces are gone. So IPv4 has been around since 1981. Nobody thought we were ever going to use all these addresses. Computers weren't really a thing. Who knew that we were going to want all these addresses? And, these companies started buying them up, and they started buying them up in large chunks. And then they sold those to ISPs, and then ISPs sell those to you. And so these IP addresses have been gone for a very, very long time. And chances are when you have an IP address and you get this IPv4, you're only going to get one. If you're a corporation, you might buy more, but we've run out of IP address space.
So IPv4 is 2 to the power 32, while IPv6 is 2 to the power 64.
There's just not enough to go around. So the theory is, okay, let's come up with something different. Let's come up with IPv6. Now, this hexadecimal is actually in 128 bits, which makes things just a little bit longer and adds quite a bit. So let's take this 2 to the 128 power. And we get a number that I cannot tell you how to say, not even going to try. But I can guarantee you that in our life,
So 3.40282366920938 times 10 to the power 38. Holy shit.
lifetime, we will never use this address space. So we've come up with the solution of IPv6.
Okay, just give me everything. Yep. There. And then MAC address. And then now this will be MAC address because I have to move fast. MAC address. Explain MAC address. Thorough explanation. Thorough explanation.
Would you like your very own Shopify store? We're literally and completely free, by the way. We are live streaming right now. Hey, would you like your very own Shopify store? We're literally and completely free, by the way. We are live streaming right.
All right, so now we're moving into layer 4, which is the transport layer of the OSI model. And we're going to talk about what is TCP and what is UDP. So we'll type that in here, TCP versus UDP. So TCP is what is known as the Transmission Control Protocol. And you could think of that as a connection-oriented protocol. And we also have UDP, which is the User Datagram Protocol. And this is a connection-less protocol. So when we have these two protocols, one is best suited when it comes to high reliability. That's TCP. TCP is connection-oriented. We want to make a connection, we need high reliability. So you can think of something like a website, which is HTTP or HTTPS. Or you can think of something like SSH or FTP, the file transfer protocol. Those all utilize TCP. When you think about UDP, you might think about something like a streaming service that's connectionless, or DNS is connectionless, or voice over IP is connectionless. And when this comes into the importance of scanning is super important. We're going to be scanning both TCP and UDP as a penetration tester. And don't worry about scanning right now. When we get into the scanning section, this will make a lot more sense. But we need to know what TCP and UDP are and define them broadly. So the most commonly used protocol that you're going to be scanning is going to be TCP. Now, TCP works on what is called a three-way handshake. Now, if we look at the three-way handshake, it's going to look something like this. We're going to first send out a SYN packet, and then we're going to receive back a SYN ACK packet. And finally, we're going to send an ACK packet. Now, how does this work? Now, you could think of this as an interaction. So let's say you have a friend or a neighbor, and you go to your neighbor and you say hello. That's a SYN. Now, SYN-ACK is going to be the response. It's going to say, hey, Syn, I acknowledge you. That's your neighbor waving hello back. And then you know you are good to go start a conversation. So that's the acknowledgement. Now, when we think about this in the terms of ports, now port is a item that can be opened on a machine. It's a way to communicate with certain protocols. For example, if you think about HTTP, that's over port 80. If you think about HTTPS, that's over port 443. There's a lot of different protocols, and there are 65,000 plus ports that can utilize these protocols. So everything related here has to do with these ports. Now, let's say that you want to connect to port 443 on a website. You're going to send out a SYN packet to that website. You're going to say, hey, I want to connect to you on port 443. And if 443 is open and available for connection, they're going to say, hey, you can go ahead and connect to me. And when you want to actually establish that connection, you're going to send that acknowledgement packet back. Now, let's make more sense of this. Let's go ahead.
Stop. Who? I got a book for it. If you did not know, I have a fucking book for it. You know what I do? I read a fucking book for once. Don't I? I read a fucking book for once. All right. I think they have good stuff. The book has good shit. Holy shit, the book has good stuff. Yeah, the book has good stuff. The book has good stuff. Right. Just get all the information. I mean, I'm just going to copy the notes. Okay, let's do all those. Wait. Okay, wait. Which book is the best for ethical hacking and cybersecurity? Penetration testing, hands-on introduction to hacking. I will learn hacking. Like I will learn penetration testing. I'll learn hacking because I want to, fucking hack. Penetration testing. All right. Let's look at the. Yeah, it's the same thing. Page what? 55. This is page 12. So 10 is 12. 10 is 12. So 9 will be 12 here. Oh, okay. exploitation, vulnerability analysis, threat modeling, exploitation, post exploitation, reporting, executive summary, whatever. Yeah, I did all that. Nessus? What's a Nessus? Why do you need a C code? Wait. Why do you need a C code? I have VMware. What's going on here? I was told to download Nessus. What? Okay, what's going on here? I want to know. I need to know what is going on here. Why do I need a C code? Just give me a few minutes. What is this for? Whoa. Huh? What do I need Windows XP for? Dude, I'm so fucking confused. What do I need a Windows XP for? Huh? Why do I need Windows XP for? Okay, wait. What is chapter 1 about? Dude, I'm good. Nah. Nope. Okay. So chapter 2. Nope, I am good. I'm not going to change anything. Like nothing. I'm good. Because I know they'll say that you have to shut down Windows and then you have to download Ubuntu. Like, nope, not doing that shit. Alright, so let's use Kali Linux. So what is going on here? Main pages. So just a quick overview, like what is going on? What is going on? Okay, so root Kali, you break it down. Okay, wait, stop. Micro step 1. Okay, so if I type ls, so I'm just going to type ls. Oh, come on. Kali ls. All right. Okay, just like, dude, I don't know, like, what's going on. You see ls, you're gonna see the list of folders. So how do you like h- okay, compress all the micro steps into one line, into one code. There you go. There you go. So root user the wait. No man, that's just too much. That's just too confusing. Okay, which okay, you made it much more confusing. Yeah, you made it much more okay, you made it much more confusing. So I am inside Linux. I am inside Linux. What are the core, programs for Linux? So I am right there. Like I am literally here now. Wait, let me just show you. So what am I supposed to code here for anything? Like yeah. So what program does what or what code does what? Okay, so bash. Yeah, I'm using it. Okay, I'm using a bash. Okay, I'm using a bash. Yeah, I mean, oh, am I inside bash? Oh, I am inside bash. Yeah, I am inside bash. So ifconfig gives me the IP address. Wait, wait. Can you use? You can use ChatGPT in Linux, right? Ho ho. Dude, you can use ChatGPT in. Oh man, this fucking mouse. Okay, I can't see my mouse pointer. How do I change that? I can't see my mouse pointer. How do I change that? Control Ultra. The- Oh no. Yeah, but then like when you click on it, holy shit, you can use ChatGPT here. What? No, you can in Kali Linux. You can use Kali Linux in ChatGPT. I mean, you can use ChatGPT in Kali Linux. Dude, I was what? Since when? So I can literally log in Google. Oh, fuck you guys. You can keep staring. You can keep staring. Four. I am using Kali Linux. Holy shit. My first X post in Kali Linux. Holy shit. Dude, I can use. Oh my god. Wait, wait. I can also do this, right? So I'm just going to go to Kali Linux, Control Ultra, hit that. Oh, I think I have to download that, right? Yeah. Penetration testing, hands-on introduction to ethical hacking PDF download. Can you do that? Dude, if I can actually download this book in Linux. Yep. Adios. You can I'm gonna do one thing for you guys. Now I'm just going to make it nice for you guys, right? You guys can stare on this. I'm gonna give you rage baits. 6 hour memes. 6 hour non-stop cringe memes. Because again, I don't care. I mean, there you go. Oh, can you use snip? Yes. Can you snip? What page was I in though? Wait, 35. Adios, boys. No. Oh, this is the real page. All right, this is the actual page. My bad. This is page 17. And we will make it double-sided. Right, no worries. So going to go to chapter 2 now. All right, it's good. Good. Yeah, you guys can watch that cow moving. Oh no, or Ooh, suckers. All right, so let's just see what is going on in terms of the directory, in terms of what are you doing? In terms of the directory, in terms of no. Yeah, allow. That's fine. Allow. Okay. Okay. Allow, yeah. That. Oh, it's like okay, so if you close that, it closes. It makes sense. Makes sense. All right, I understood what's going on. But how do you make it like double-sided? I'm going to quickly snip all of it. So I'm going to quickly snip all those. Sorry about it. I think the most of chapter 2. What is this? Holy fuck, I don't have this book. Let's just quickly. Don't worry. It's just cow dancing. Don't worry. You can go one more. All right. One micro step, please. Good luck. Okay, so I'm currently using Linux. Okay, let me ask one more thing. Don't answer anything. I'm using Linux. I'm inside Linux at the moment. So I'm literally learning this from Linux. I'm literally learning from you from Linux. However, my pointer like vanishes and I want my pointer to be permanent. You know what? Not now. You have man ls, the manual reading, and what does it do? The man ls, so you're gonna learn some manual ls. Let's try that. You have man ls. Is it possible to, okay, you can enlarge it. This is good. This is great. This is great. So this is what we have so far. Okay. So this is what I see so far. So when I clicked manual ls, so man ls, so this is what I see so far. Is it good? Is it what I'm supposed to see? So I, integrated man ls. This is what I see so far. See so far. I think I'm going. I think from now on I'm going to use X, not X. What's Pokemon Go? What is Pokemon Go? How the do you walk with a Pokemon Go? Okay, so man ls. So you have the list. So ls means the list of directory contents. So these are the Linux commands. So ls is just the list of directory commands. So ls is just the list of directory commands. And so when you have manual ls, some star 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 star, that is ls. Don't write L in capital, but small l and I, small l and I are the same thing. Reads, I mean, looks the same. Anyways, when you do that, you're going to read what Linux does here is that it reads the files manually, one by one. All right. ls just list. So ls just list the document, like the folders and whatever exists, folders and whatever exists. Let's move to the next one. Let's not do micro step. Let's not do micro step. Let's do one image, like break, like as you explain that one image, meaning there are two pages, easily explain what is going on. Explain what is going on. Again, I am new to cybersecurity. Yeah, so I type man ls. Okay, so what am I okay, wait. What the fuck is going on? What am I supposed to do? All right. All right, so what am I seeing here? Okay, let's move to the next one. Okay, man ls. So it gives a description of everything, right? It gives a description of everything. So man ls, it reads the description of the files. Right? It reads the descriptions of the files. Cool, good stuff. And now they have top line. So you see ls1. So ls is a command. One, it belongs to the user command. Okay, ls is a list document directory contents. Synopsis would have ls of option. So ls plus optional flag plus optional target. So lsa or ls documents or lsl documents. Okay, so if I type, so this is synopsis. So let's do synopsis. Okay, where is it? So let's do ls document. Okay, I can't access it. The ls document. So are we in? So I did ls documents. Are we inside documents now? So here I did ls documents. Obviously not the first one, the second one. So the second one I did ls documents. The second one I did ls documents. So are we inside documents now? The first one is wrong. The first one was wrong. It's wrong. Don't worry about that. Oh, okay. So ls documents means you just see the documents folder. So it's like you're seeing the documents folder. Okay. So what was number 3 again? Synopsis. So ls is just seeing the what does lsa what does lsa holy fuck, what is this? lsl desktop, ls desktop. Okay, what does each of those I have a question. What does each of those mean? Okay, what is this? Oh, okay. You're mentioning it. So small a is all, capital A is almost all. So small a is all, meaning all of it. Small l is the detailed information like the permissions or so if I write, let's see, if I write lsl desktop. Okay, yeah, actually, good question. So I did write. So what would they mean? So what I have is so lsa, lsl. This is what I see at the moment. So this is what I'm seeing at the moment. This is what I am seeing at the moment. What does each of those mean? Each of those mean? So LSA shows everything. LSL is what though? The only reason I'm seeing, so if I write LSA, what the folders that I'm seeing are inside Linux. These are the folders that I'm seeing inside Linux. And the only reason I see desktop empty, so LSL desktop, there is 0 because there is nothing in the desktop for Kali Linux. Because I'm not inside Windows, I'm inside Kali Linux. And if I write LSL, let's write LSL. Let's move to the next image. Let's move to the next image. For the answer for that means there are 0 folders or apps or anything downloaded inside the desktop. Okay, fine, it's the same thing. So I'm actually going to plot this. So few directories, few dictionaries to know, few stuff to know. So A L A. So LSA means every single existing document inside your OS. That includes the hidden files. LSL means the details of each of those, the details, like the details of the file you selected. If you have ls lsl, this just means a detailed information for every single file, for every single file. Oh, definitely, I'm going to go out. Definitely, dude. I don't want to even stay home. So LSL and LSA means almost every single thing. Not all of it. Not all of it. Almost every single thing. Right. Let's move to the next image now. Did we do this? So the next one is like creating files and folders. Next is creating files and folders. So this is Bash. Holy shit, I'm actually learning Bash. Creating files and folders. So touch my file. So you create a file. So you create an empty file named my file. What's mkd? Creates a new directory for file. And then ls, obviously we know what ls is. And then cd my directory. So you go inside the directory. So touch means creates a file. So like, a Word file or a so mkd creates a folder named test. Creates a file. So touch creates a file. Mkd creates a folder. Ls sees the folder, and cd goes inside the folder. If I have, actually, you know what? Where is it? Touch, mkdir, ls, and cd. So creates a file. Keyword file. So Microsoft Word file or Excel file or a Notepad file. Like for example, Word file or Excel file or TXT file, like that. And then mkd creates a folder. So it creates a new folder. Example. I don't know. Fall 2026. Something like that. Fall 2026 courses. ls is the folder, meaning you only get to see the folder. Like as in, okay, the file exists. As in, all right, the file exists. File exists. But you're not going inside the folder. Now, this means going inside the folder. So it's like, so here ls is like you see a door. cd is like going inside the door, kind of like that. But I also have a feeling that, are we missing anything else? Are we missing anything else from your explanation? Are we missing anything else from your explanation? Because I need to be somebody, please. What you're not missing. Copy, move. Okay, so is that on the next image or what? Man, I just don't even want to fucking study, man. Oh, wait, which image are we in? Which image are we in? I lost count. Oh, even he lost count. For fuck's sake, man. Okay, creating new file, copying. Oh, so CP is what? CP is copying file 1, file 2. MV is so CP is copying the file. MV is moving the file or renaming the file. And RM is deleting the file. Okay, wait, can you do an example for just wait. Can you do an example for this? Okay, I'm gonna copy that here too. The copying, creating, renaming, like modifying a file. We're just going to say modifying a file. Modifying a file. Oh wait, it's not working anymore? Holy shit. There you go. So we have copying the file, moving the file, renaming the file, and viewing the file. Wait. Oh no, no. Stop. Stop. This, this, and then writing into a file, overwrites the file, and I'm going to copy all those. Copy all those here. So copying the file, moving the file, renaming the file. CP is what? Okay, CAT is viewing what's inside the file. That is viewing what's inside the file. Like whatever the file you opened, like what exists inside the file. So if you want to open a Word document, then you're going to say cat my Word document, and then you're going to see probably a paragraph, or probably you're going to see a passage, whatever. And then writing into a file. Writing into a file. I don't know what is writing. Oh, writing into a file. And then read, write, execute. Now these all, like, can you show an example? Like, how do you, like, how does what happens with the example you mentioned? Can you show an example, like example of you implementing it, and then explain what happens to that specific example? So touch file1, so it creates a file named file1. Then you write hello into file1, and then you view the file1, then you copy the file1 into file. Okay, you copy file1 into file2, and then you rename, because file1 is the source, file2 is the destination, and then you rename file1, file2 as file3. Change the permission. The chmod to change. What does change the permission mean? So touch file1, it creates an empty file. Echo hello to file1. So you write something into the file. So in this case, he wrote hello into file1. And then cat file1. So you see what's inside the file1. So inside the file1 is written hello. And cp file1 file2. So whatever the contents that exist in file1, you're going to copy the same content into another file. Let's say the other file named file2. So hello will exist in file1, and hello will also exist in file2. And then mv of file2 and file3. Now file2 is renamed to file3, right? File2 is renamed to file3. And so instead of file1 file2, you're going to have file1 file3. Then chmod, it adds an execution permission, because initially you're going to have read write, and you're going to have read write execute, so you can now run it like a program. All right. And then rm file1, so it deletes file1. Makes sense. I'm just going to snip this here. And 3, 4. Five, 6. Yeah, I also have the before and after for the execution permission. I'm doing that in a second. With this one here. And 7. Good. It adds. It adds. Or does it replace? Okay, so it replaces. Okay, so this. So what will happen is, actually, let me. So key stuff for echo. If this, meaning whatever content is inside the file, it gets replaced. And if this, meaning whatever content is inside the file and you want to add a new let's say new text, it adds it. So if I have example, if I have echo hello file1. So inside the and then I'm going to write cd file1, then I'm going to write echo world file1, and then cd file1. So initially inside file1, you're going to read hello. Then when you add world file 1, the hello gets replaced to world. Now, if I have the same thing, you copy it, and this gets appended. The world gets appended alongside hello. Anyways, let's move to the next step. Permissions. So touch, script sh, and then echo echo. What does that mean? So what does that mean? The permission. So we'll use one simple example. So touch script.sh echo echo hello script sh. What does that mean? You group. Okay, wait, stop. You're making it very what the fuck? Fuck, you're making it very confusing. Calm down. Confusing. Calm down. What's going on? So you made a file, script.sh. Oh, so okay. So to create a file, it is touch script.sh. File is like you're not allowed to run. So Linux says you'll not be allowed to run this. Why? Because of RWRR, which is read and write. All right, let's actually run this. So I will. What I'm going to do is I'm going to create a file called script sh. So script. Okay, actually touch script.sh. Echo echo. So echo echo. Hello script sh. Then ls l script.sh. And I have to change the permission of it. So view group others. This is what I can do. Actually, you know what? I'm going to copy this here. This is the chmod accessing permission. The chmod accessing permissions. So RWRR. So you have what I can do, what the group can do, what others can do. Explanation of this. Now what? So you add the permission chmod x script.sh. Then I'm going to add so chmod x script.sh. And then now if I write ls l script.sh, okay, it's still the same thing though. Let me try one more time. Oh, it should be plus chmod x script.sh. Oh, chmod plus x, sorry, chmod plus x script.sh, then ls l script.sh. All right, now we good. So this is after adding the shit, my bad. So this is after adding the permission. After adding the permission to execute the program / file. Yeah, I think I'm going to stop here.